Okay, so we're still in serverless and I'm hoping to finish it perhaps today. If not, then definitely a little bit, mainly a little bit of time next week. So I want to walk through these slides here. And the lab for the coming week is this lab here. So in the lab just gone, what you've been doing is creating lambdas and generating URLs for those lambdas so that you can trigger them from a web-based client, be that Postman or even a browser. But the URLs that are generated are kind of completely independent of one another. They're not in any way uh, connected. So, and presumably the lambdas collectively perform some sort of, they kind of represent some overall application and implement individual parts of that overall application's functionality. So what we'd like to do is to combine them together in some way from a client's perspective anyway. Uh, in short, what we want to do is to develop a web API interface to the backend, where the backend is represented by our Lambdas and our DynamoDB. Okay, so in the subtitle of this slide here, we're talking about AWS related services uh, for web APIs. And the main service or the service to help us achieve that is a service called API Gateway. And it allows us to develop either RESTful web APIs. You might remember that REST characteristic of web APIs that you would have touched on in the web app dev last year. There are kind of two types of web APIs from AWS's perspective anyway. There are RESTful web APIs and there are what they call HTTP web APIs. There's a little difference between them. The HTTP ones tend to be cheaper from a cost point of view. We will uh, focus on the RESTful web APIs. That there's a lot more capability provided by AWS for RESTful web APIs than HTTP web APIs. But in a production environment, organizations may well prefer to go for the HTTP option, probably because they don't need all the kind of bells and whistles that the RESTful web API provide. So that's going to be the topic for the start of today's lecture. How do we create a RESTful web API interface to our backend functionality? And so we've seen this kind of image before. This is my representation of the different aspects of a serverless application. And today we're looking at what's kind of loosely linked to the communications part of a web application. That's where API Gateway kind of fits in. So as I've already kind of indicated, what API Gateway is all about is, again, it's a fully managed service, which we know now is a byword for serverless. We don't have to configure any kind of servers related to this. So it's a serverless or fully managed service for developing web APIs, be they RESTful web APIs or non-RESTful web APIs. Non-RESTful is what AWS refers to as plain old ordinary HTTP APIs. And so the picture is your kind of classic three-tier architecture that we're going for. So whatever the client is, the client could be a mobile app, it could be a web app, it could even be a desktop application, and it wants to trigger a lambda. Now, in general, like there are a whole bunch of lambdas here. That's what we've kind of got to imagine. And the API gateway provides a single kind of point of entry to one of the lambdas. And whichever lambda is triggered will depend on the URL that the client tries to send a request to. Okay, so I guess the issue is how do we configure this part of our application? We know about this stuff here. We know about the Lambdas and uh, talking to DynamoDB or talking to any other service. We haven't had our Lambdas talk to any other service so far, but we will do that later on in the module. Um, but it's configuring this here, and also how do we integrate our gateway with our Lambda backends. So API Gateway, there are, as I said, there are lots of aspects, there are lots of bells and whistles that come with it, most of which we won't actually look at, but and I'm kind of listing as many of them as I can here. Like it handles API versioning, like in the real world, an organization that provides a RESTful web API interface to its clients, whatever its clients are. That web API will evolve over time, but they still need to provide the older versions of the web API to their older clients because their older clients may have developed client-side software that communicates with the old version of the web API. So we'd like API Gateway to be able to support versioning of the web API so that we can have multiple versions of our web API available at any time. And API Gateway does provide that feature to it, even though we won't look at it. Also, when you're developing a web API, you're going to have a dev environment, you're going to have a test environment, and you're going to have a prod environment, and you'd like API Gateway to make it easy for you to have those different environments. And it does. It also handles security, uh, mainly using another service called Cognito, which I hope to start looking at today. Um, so API Gateway and Cognito kind of go hand in hand. Creating API keys, there are kind of two ways that you might allow users to use your web API. You either give them a username and password, so that's your kind of classic login authentication method, or you might generate an API key for your users, and then they include that API key in the various requests that they send to your web API. Well, you can get API Gateway to auto-generate these API keys if that's your preferred means of authentication. Request throttling is something that you can configure. You want to actually maybe limit users' amount of requests that they can send to you over a particular period of time, which is what we refer to as throttling. And you can configure your web API to achieve that. It supports Swagger, which you might remember from last year. Swagger is a way of documenting the structure of your web API from your client's perspective. OpenAPI is an alternative to Swagger. Supports the WebSocket protocol. So if you actually want to be able to communicate with your client in a kind of a push rather than pull model, then WebSockets are this kind of push idea. Um, what else? Transformation of the and validation of the requests. So if I go back to here, maybe you'd like the API gateway to perform a certain amount of validation of the requests before it passes it on to whatever the backend is. Or maybe you'd want the API gateway to do a transformation of, let's say, the payload that comes with a request, transform it from one form to another form before it passes it on to the backend. There are some people who argue that that kind of behavior, because it is really behavior, should not be programmed at the gateway level. That should be programmed more at the backend level. But that's just a debate for the kind of the purists. You can get the API gateway to generate an SDK of your web API. Again, if I go back here, rather than whoever develops the client, for communicating with your web API, rather than the the client actually sending raw HTTP requests and programming that into the client software, it would be nice if there was an SDK that came with the web API that you had developed, an SDK that the client can now actually use. And generating those SDKs from an API configuration is pretty much an automatable task, and API Gateway does that for you, etc. Right? Caching, it can perform caching of API requests rather than going to the back end all of the time. Maybe it can send a cached response back to the client. And also direct denial of service, it actually protects you from that. So there's lots of stuff that you can configure related to your particular web API. But as I said at the outset, most of these we won't actually get a chance to look at. But it's just all configuration anyway, so it's not that big a deal. Now, by integration types here, we're talking about how do we connect our web API with our backend? How do we integrate them? And there are four, I think, integration types or integration models that the API Gateway Service provides. One is a kind of a dummy one, really. It's called mock integration. So you actually don't have anything at the back end. You just get the API Gateway to send a standard kind of static pre-configured response to a request. So these mock integration types might be useful as you're developing your web API before you actually have any functionality at the back end. So it's kind of the kind of default case, really. The next type of integration, now, unfortunately, when you read up about these integrations, there are different names given to them, which is unfortunate. And even AWS's own documentation is a little bit inconsistent. So I'm going to call it anyway the HTTP AWS integration. It's also referred to as the AWS services integration. And the idea here is that what you actually have to do as the developer of your web API is you have to write what are called mapping templates. So these mapping templates are part of the web API that you have created. And what the mapping templates do is they describe how a request should be transformed before it is passed on to the backend. So for example, here, if the backend is actually, it's not a Lambda at all, it's an SQSQ. For that type of backend, you are going to have to describe in your web API how is a HTTP request transformed before it can be written to an SQSQ. Yeah, and you do this by means of these mapping templates, which are written in a special purpose language, which isn't actually I think it's called Velocity. It's quite an old language that AWS adopted for this particular purpose. So anyway, that's what's classified as HTTP AWS. Essentially, you're kind of going from the HTTP world, which exists here, to the internal AWS network world. Yeah, and there needs to be some way of transforming from one to the other. We won't be using this integration type anyway, but that's what it's there for. The next one, which is the one that we will be using most often, is, again, it has multiple names. It's called AWS Proxy. It's also called Lambda Proxy, which is probably the best name to give it, really. And what this integration type is specifically for when the backend is actual Lambdas. And you just tell the API Gateway, I want to use the Lambda integration, the AWS Proxy integration for a particular endpoint in my web API. Yeah. And it takes care of the rest really. You don't need any mapping templates at all. Now, so we've got a HTTP request here, right? Hitting our web API. And there does need to be a transformation before that request can be passed on to our Lambda. We know that the Lambda expects an event object, right? So how do we transform our HTTP request into an event object? Well, fortunately, API Gateway will do it for us, provided we tell it this is the type of integration that you need to perform for me. And in particular, um, like obviously the payload in the request is fine. That's just a JSON document, so I can pass that on as a JSON document onto your Lambda. If your Lambda happens to be written in TypeScript stroke JavaScript, then that JSON document is just a JavaScript object. But maybe the HTTP request has a query string part to it. Maybe it has path parameters. So how do we provide those in the event object? Well, it turns out that they will be just added on as extra properties in the event object itself. And we'll see that in a few slides. So this AWS proxy stroke lambdas proxy integration type is specifically for when the back end of your web API is a Lambda function. The fourth type of integration is called HTTP proxy. And really all that happens with this type of integration is the HTTP request is essentially the exact same that's passed down to the back end. An example of where you would use this is if the backend is a load balancer. So this API gateway, it can be the front end of the client-facing side of multiple types of backends. Application load balancer, in the previous one, we have Lambda. In the previous slide, we have SQS, or it could be SNS. So it could be any type of backend behind your API, your web API, or it could be a mixture of them. You might have a web API which is integrated with an SQS queue and a couple of Lambdas and an application load balancer. It doesn't have to be just one type of backend. It could be a conglomerate of types of backends. So, okay, all a bit theoretical so far. That's the whole area of integration types when you're creating a web API using the API Gateway service. You have to tell the API Gateway service the type of integration that you want to have enabled for particular parts of your web API. Okay. The other thing is CORS is a central part of any web API. You might remember CORS certainly from the web app dev module, and you've probably come across it in other places as well. The image here is trying to explain or remind you about what CORS is all about. Let's supposing our client is a web app. Let's say it's a React app you are familiar with from last year. Now, just by the way, right, we could actually deploy a React app into an S3 bucket, which is a very common thing to do. So that's why we're representing, we have a bucket here, which is representing an S3 bucket in the Amazon world. So we can deploy our web app there. And let's supposing the web app, its domain name is this, www.example.com. Okay, so that's its domain name. Whereas over here, we have a web API with some backend that we're not interested in. We have a web API, and it also has a domain name called apiexample.com. So clearly, they are different domains. And so if this React app is loaded into a browser, okay, and it wants to communicate with the API on the right, then what it first of all has to do is it has to ask the web API what domains other than your own or what origins other than your own do you accept requests from. So that comes in the form of this pre-flight request response. So the pre-flight request, this kind of happens behind the scenes unbeknownst to you, as you know. The pre-flight request asks the API, the web API, what requests you accept from origins other than your own, i.e. cross origins. It responds telling it what other origins or what origins other than its own it accepts. So if it comes back with a response that says, I accept everything, well, here it's being specific about what other origins it accepts requests from, which happens to coincide with the domain name of the client. And if the response that comes back, these are HTTP headers. I'm not going into detail about these because I'm assuming you're familiar with the CORS protocol. But in the pre-flight response, that's telling the client it either can or cannot send the request. And if it can, then it sends the request on as normal to trigger whatever backend is over here. So the summary is you have to always configure the CORS settings for a web API that you are developing using the API Gateway service. Let's develop a simple web API using API Gateway and our friend the CDK framework. And it's your kind of boringly standard. I want to manage to-dos. Okay, and here's the structure of my web API. So I want to have a to-dos endpoint. Remember, we talked about endpoints when we talk about web APIs. I have a to-dos endpoint, and it supports both a get and post request. And that's what the get does, and this is what the post does. I also want to have a /todos/to-do ID endpoint, and it only supports GET requests, and clearly a GET request to this endpoint, the idea is that we want the response to return back the full details of a particular to-do. You might remember this part of the URL is referred to as a path parameter. This is the entire path. The entire path is made up of a static part and a variable part. And the variable part is also referred to as a path parameter or path variable. So this is the web API that I want to implement. Okay, we don't care about the lambdas behind them. In my case, the lambda is just a dummy lambda, and I'm actually using the exact same lambda for all three. They all go to the same dummy lambda because, all the lambda might do in reality is read and write from a database, and we know how to do that. Okay, that's the objective. When I actually create this web API, then let's see. Let's just flick over to here. So there's the service that we're interested in is this API Gateway service, which is here. And, when you click on this part here, it lists all of the web APIs that I have developed in my account. And it looks like there's only one at the moment. This is this one here. And I guess maybe I should just look at the actual code that created this. Or maybe before I do that, what I'll do is if I just click on it, And it's showing me here the structure of my web API, which is kind of consistent with what I had on the slide there. So there's a root path, then there's a to-dos subpath within that. The to-dos path supports a get and post requests. It also selects and accepts options requests which we're not interested in. And furthermore, there is a slash to do ID extension of the to dos path. And again, it's using the curly braces to indicate that this is an actual variable rather than a static string. And it supports GET requests. This particular endpoint supports GET requests. And if I click on any one of these, let's say I click on this one, um, I'm getting some detailed information here on the right on that particular endpoint. And it's actually showing me the integration type. If I scan across here, showing me that the integration type is Lambda integration, which is kind of a shorthand for our AWS, our Lambda proxy integration. I did say there are different names, and so it's calling it just Lambda integration here. So the kind of visual is nice, I think. So here's our client, whatever the client is, goes through API gateway, and eventually it finishes up with triggering a Lambda. Okay, so how did I actually write my CDK code to produce all of this? Just pause for a second in case, God forbid, there are any questions so far. No. Okay, all this slide is showing you is what I've actually shown you in the browser. And so here's a screenshot of the CDK code, and maybe I'll just look at this in Visual Studio. And as I said, the lambdas we're not interested in, there's only one lambda, and it's the same lambda that's being used as the backend for all of my endpoints. And look, all it does is does a console log and returns just a status 200. So that's not really of any interest. This is where, in the stack file, is where I write my CDK code to provision, use that word, to provision a RESTful web API using the API Gateway service. Okay, this is just creating my Lambda. Nothing interesting there. And here we go. We're creating a new REST API. This REST API is imported from, where are we? Oh yeah, from here. Yeah, so it's from my CDK lib package, which we've been using a lot so far. Anyway, so create essentially an empty web API. That's all this bit of code does. Just collapse that. And okay, the description, which is really arbitrary. The deployment option. Um, Remember, we said that we'd like API Gateway to be able to support different environments, dev, prod, test. Well, this is where you can kind of set, and it doesn't have to be dev, prov, test. You could have other environment names, like staging is another one that's used a lot in industry. So because really it's essentially a string, but you can set the environment here, okay? And really how that affects your API gateway is the the environment name will appear as part of the URL of your web API. So we will see /dev/todos appearing in our URLs for our web API. But again, I think that's actually arbitrary. If left it out, I think it defaults to dev. And here we have our friend, the CORS settings, right? And I've just made it very open-ended. Okay. From here on down, then, is where we start adding in the various endpoints to our web API. So first of all, and it doesn't use the term endpoints, it talks about resources. So we have, if I go back to my slides, this is one resource. This is another. Sorry, there's too many lines there. This is a resource. This is another resource. And each resource can have a number of methods associated with it. So really, in our CDK code, what we've got to do is build up these resources, also indicate what methods are supported for each resource, and what is the integration type for each of these methods. Integration type comes at the method level, as you would see. So we're adding a resource where the path name is the static string todos, and we're adding it to the root resource. Here then we're adding a method to that resource, and we're adding the get method, and here's how we code the integration that we want behind the backend integration that we want behind that method. This is how we do it in CDK world anyway. Okay, so there's this convenience class called Lambda integration, and you essentially pass it a reference to a Lambda function. This is the Lambda function that I have at the top of my file, okay, which is just a dummy, as we know. And I'm also reinforcing the fact that the nature of the integration, not only is it a Lambda that's behind it at the back end, but I want the integration to be kind of a proxy nature. So the payload is from the HTTP world is just proxied over into my my event object that's passed to my Lambda. So to a degree, this is kind of boilerplate. And we keep on going, okay? We're adding a second method to the same resource stroke endpoint. In this case, it's a post method. Here's the integration. Here we're creating a new resource, but we're adding this resource. We're not adding it to the root. We're adding the resource to the resource that we've already created. Okay. And here's the path associated with that resource. And because I've put curly braces around it, that kind of tells API Gateway that this is actually a path parameter. And the integration is there anything different about it? Oh, sorry. So this is a new resource stroke endpoint. And then I start adding my methods to that endpoint, which is what I'm doing here. Yeah. So that's the CDK code. Pretty straightforward, I think, once you've studied it for a little while. And so you run CDK deploy of that stack, which I did earlier, and it automatically gives you the domain name for your web API. So it's a single domain name for your entire set of endpoints, unlike in the lab this week where you had a different domain name for each Lambda function. So if I just bring up this, and I don't need to use Postman in this case anyway. And if I go straight to it, now you can see the URL here has /dev automatically built into it. That's because I set my environment to dev. And so if I go to do's, which is one of the endpoints, then here's the response back. And that should be consistent with my Lambda. Yeah, it just sends a 200 message success. So I've triggered my Lambda. And the other endpoint was, we're not going to see any difference really, but actually what I might do is if I go into CloudWatch, because my Lambda is doing a console log of the event. So let's go to CloudWatch logs. And I'm just going to clean out the logs from any other stuff that I might have been playing around with. And if I just do a refresh of this, go back and check my logs. Only one log stream because I've only ran it once. And the console log in my Lambda is console logging the event. And so if I expand this one here, here's the full event, and there's lots of stuff in there. We can actually get access to all of the HTTP headers that came in with the HTTP request should we want those. And we will later on actually, but there's lots of headers really, many of them just auto-generated by my browser. But if I scroll down further in the event to, let's see, you can see here, right? If there was a query string in the URL, then I can get access to remember a query string is just a set of key value pairs. I can get at those key value pairs from within the event object. And similarly, if there were any path parameters, then I can get access to those within the event object. And so the transforming of the HTTP request into my event object, okay, that is being performed by virtue of the Lambda integration that I defined for the particular method of the particular resource within my web API. And again, that is something that we will be interested in this week's lab and further down the line as well. And to that point, right? So when you're using this AWS proxy, whatever you want to call it, or Lambda proxy integration, the query string is packaged inside the event object. And I've just illustrated that to you. And here's another example of it. So if I send a request to my to-dos app there, even though I'm not processing the query string, if I tag down that query string onto a particular request, then this is what my Lambda function can access inside of the event object in order to extract the query string parameters and do whatever processing it wants to with them. Similarly, if there are path parameters, as there would have been in our case, so we had a /todo/a to-do ID, how does my Lambda get access to that? And the answer again is it's contained within the event object that the API gateway passes to your Lambda. And again, the screenshot is showing you what it would look like for this particular invocation. And you might remember I called my path parameter to-do ID. So this key here is dictated by whatever you put there. And it's completely arbitrary. Okay. And that's it really. That's as much as we will cover from an API gateway perspective. Although, as I showed you in one of the very first slides, there are many, many other features that we could have that we can configure for our web APIs. The next service I want to look at is Amazon Cognito. And in terms of our kind of global view of the different parts that make up a serverless application, I'm saying Cognito fits into the kind of state management part. We've already looked at DynamoDB, which manages state as well. Cognito is also a state management part in the sense that it manages the various user accounts information. So rather than storing user accounts in our DynamoDB database, we could do that, but instead, though, a better option would be to use the service Cognito, which is specifically for that purpose. So storing usernames, passwords, and really anything else that you want to hold information on about a user. So it's when we want to give users some sort of unique identity to allow them to access our applications. In this case, it's well, it's typically web API based applications, although it doesn't have to be that. That is the context in which we will look at this Cognito service. Now, the Cognito service has two types of resources. This is resources now in the AWS sense of resources, not in the sense of web APIs. There are two types of resources that you can create. One is called a Cognito user pool, and the other is called a Cognito identity pool. The Cognito user pool, which is the one that we will focus on, that's for your kind of classic supporting of sign-in registration type behavior. And so it's typically used in conjunction with API gateway and indeed application load balancer if you're developing a more traditional type of application. An application load balancer, as you know, is essentially kind of playing the same role as an API gateway. So, but these are API gateway, as we know now, specifically for developing RESTful web APIs. The Cognito Identity Pool, again, it's more related to when you want to give your individual users their own AWS credentials, like an access key and a secret access key, and you want to manage those credentials for the various users. But those users typically, what they want to do is to access directly some resources within your AWS account, be that an S3 bucket or whatever. So to give them direct access to some of your AWS resources. How you manage that is you create an identity pool and you kind of register you as the administrator, register users in that identity pool. It generates the various keys and you provide those keys by whatever means to your users. Okay, so clearly we're not going to be looking at that. You can integrate Cognito identity pools and user pools. So you may have a scenario where you want to give users not only uh, login credentials, username, password type credentials, but also you want to give them access keys so that they can directly access some of your AWS resources. And again, the S3 bucket is probably the best example. You may want to actually allow more traditional type of users to upload stuff into an S3 bucket. And that uploading might trigger some behavior. So Cognito is very much in the kind of security part of the AWS platform. And we know IAM is all about security. So if we're trying to say, well, should we use IAM or should we use Cognito for a particular scenario? A very simple way of distinguishing whether you should go for Cognito or the IAM route. The IAM route, again, would be, you create IAM users, you go down that route, which you've done. But again, um, it's quite demanding from a labor perspective to go creating all of these IAM users. So if you've got sort of hundreds of users, then clearly the IAM route is not a good route. Go down the Cognito route. Also, if you've got users that want to access your applications stroke resources from a kind of a mobile platform, then the Cognito route rather than the IAM route is a better option. So we're just focusing on Cognito user pools, which are aimed at, your kind of standard registration, login type behavior. And it is behavior because there is processing associated with registration and login, but the processing is pretty standard. So rather than you having to write Lambda functions to deal with that, then, it's kind of built into the Cognito user pool support, as we'll see. There is a certain amount of Lambda that you have to still write, though. You're not completely, it's not all just clicking things here and there, and suddenly it's all generated for you. So that's slightly misleading to say that you don't have to write some of the behavior behind registration, as we'll see. So these Cognito user pools are for about creating a serverless users, and I'm saying a database here in quotes, and essentially that's kind of what a user pool is. It's a database of your users. You don't treat it as a traditional database, though. It provides your kind of standard login behavior and all of the other things that are kind of associated with this, like the ability to reset passwords, multi-factor authentication. It supports federated identity. So, we've all used applications where we use our Facebook or Google or even GitHub credentials to register for an account on a particular web application. You can build that into your web APIs if that's your preferred approach, rather than forcing the user to come up with a username and password. You can block users. It supports JSON Web Tokens, which is something we'll see a lot of actually, as a way of authenticating subsequent requests from a user after they've logged in. So it's all the kind of standard stuff that you associated with creating user accounts. At a very high level, this is kind of the way it works. So again, you've got some sort of a client, be it a web application, a mobile application, a desktop application, and the kind of login stroke registration is all handled by Cognito. And typically, when you log in, what Cognito does is it checks that you are a valid user, and then it returns some sort of a token. And then you use that token for subsequent requests that you send to an API gateway, which is where all the actual applications logic is. Pretty standard stuff. So from a CDK point of view, how do we create a user pool? This is just showing you. So it's, again, kind of boilerplate. You do have to indicate when you're creating a user pool what are the aliases for username, and I'm just indicating here that emails will be used as usernames. This setting here is if you want to allow users to self kind of register for your application as opposed to the administrator registering everybody. And so we're enabling that. And all this is saying is if I destroy my CDK stack, do I want my user pool to be destroyed as well? And clearly in a development environment, that would be preferable. In a production environment, probably not. Now, as well as creating a user pool resource, again, now I'm using the word resource here now in the context of AWS. As well as creating a user pool resource, you also have to create what's called a client for that user pool. This client now is on the server side. And later on, we will have Lambda functions which will be communicating with the Cognito service for the purpose of accessing our user pool. But those Lambdas, they will use this client here to communicate or to manipulate the user pool. Okay, so it's just an additional step, right? Again, though, it's boilerplate. So you always have to have a client in conjunction with your user pool. Now, let me just flick over to here. So this application is going to be demonstrating all of the Cognito stuff that I want to walk through. And I'm just going to deploy it while I'm doing some talking. Probably should have deployed it already. Okay, so we let that work away. The screenshot is just showing you the Cognito service management console, and it's just showing evidence of the user pool. We might look at that in a moment when the stack is deployed. Now, what I want to do is to walk through this example stack, and it's kind of you could regard this now as a more detailed representation of this, right? This is a kind of very high level illustration of how Cognito works in conjunction with API Gateway. This is a more detailed one though. And typically, although you don't have to, but typically what you do is you have two web APIs. One web API is dealing with all of the authentication authorization aspect of your overall application. And the other web API is the one that is fronting all of your the actual application logic itself. So we can imagine all of our lambdas here that talk to DynamoDB. That's what's going on over here. And all of that is sitting behind one web API. And you have a separate web API just for dealing with authentication related behavior. You don't have to, you can combine them all together, but I think this is a better separation of concerns, and it's the architecture that you will see a lot in industry. And so the typical kind of flow is user comes along using whatever nature client that they're using, and they log in. And let's assume they've already registered, but if they haven't, the registration kind of process goes through this web API as well. And the registration will involve, you know, creating an account for them in your Cognito user pool. But after registration, then the login process is as you might expect. They log in with their credentials. Sorry, username, password credentials. This web API is going to forward that request onto a particular Lambda. There are a number of Lambdas here as well, which we do have to write. One of the Lambdas is dealing with just the login process. And, you know, it's going to talk to the Cognito user pool via the actual client that we had to create there. And the purpose of the communication is to obviously validate the username password combination. And if Cognito is happy with the combination, then Cognito will generate a JWT token, return that back to my Lambda, and that is returned back in the response back to the user. And then that token is used subsequently for any requests that hit this web API. Of course, that token has to be verified, and the verification is performed by another Lambda function, which we often refer to as the authorizer. This Lambda, and I should have really put in a connection here, this Lambda is going to be communicating with the Cognito service, and in particular, the Cognito user pool within that service that is related to this application, passing the JWT token. And what Cognito will do here is verify that that token was generated by it for that particular user. And if it's happy, then it will respond to that effect back to my this authorizer Lambda function here, which we have to write. And that will then tell API Gateway, you can either allow the request to go to the backend, or you should deny it and send an error response back to the user. So we need to look at how do we set up all of this. We know how to set up a web APIs, okay? We've just seen how to create a user pool. And we'll have to look at these lambdas here, this lambda here. We don't care about the stuff that's over here. Okay, so that seems to have deployed, and one thing we can look at is the Cognito service. And if we look at the user pools, and this is the user pool that my stack created. And currently there are no users in that pool. So that's okay. So here's the entire project. And let's say we start in the lib folder. So here's my stack file. And here's the code I've already shown you. Right? Create my user pool, create my client linked to that particular user pool. I'm just getting the unique ID of the user pool, and I'm getting the unique ID of the client. Now, the rest of the stack would be about creating my web APIs and my Lambda backends, and in particular, uh, these Lambdas here and this Lambda here. I don't care about these, okay? So the rest of the stack is about creating all of that. The Lambdas, this API, this web API, and this Lambda. So there's quite a lot there, right? Now, seeing as we've split it up into two nice separate parts, then can we avail of that? Can we kind of represent that in our code in some way? And one way of doing it when you're using the CDK framework is, you might remember when I introduced the CDK, I said that the CDK, your CDK code is made up of instances of constructs. There were L1 constructs, L2 constructs, and L3 constructs. And we've seen a lot of the L2 constructs and those that are actually provided by the AWS framework itself. So for example, when we want to create a Lambda resource, we used an L2 construct that allowed us to do that. When we wanted to create a DynamoDB table, we used an L2 construct provided by the CDK framework that allowed us to do that. But we can also create our own constructs, and they would typically be in the L2 category. So wouldn't it be a good idea maybe to put all of this into an L2 construct and maybe put all of this into a separate L2 construct? I guess this guy would probably be in this construct over here. But either way, we can break our overall stack into custom constructs. Just from a programming point of view, it's a better breakdown of our code. And that's what I've done here, right? These two files here represent two constructs that I've created for myself. And you can kind of tell from maybe the name, it looks like that this file here is the construct that will generate all of the AWS resources related to the top web API in the diagram that I'm showing you there, the authentication related web API and its associated lambdas. This file here is going to contain the code that generates the bottom web API in my diagram, the actual application API. So again, going back to the stack file, what I'm doing here is I'm actually creating an instance of my two constructs, right? And that's the end of my stack file. So create the user pool client, and create an instance of one instance of each of my custom constructs. So I need to now look at inside these custom constructs. And the first thing I'll just say to you is, you can see this class here. Sorry now. So now just give me one moment. Oh yeah, you see this class here extends the stack superclass. Whereas if I go into one of my custom constructs, and let's look at this one. To create a custom construct, you also write a class file. Or sorry, you create a class. You can give the class any name you want to, but in this case, it extends the predefined construct superclass that's provided by the framework. So straight away, this is telling us that this file here is not a stack file. It's actually a custom construct file. And the rest of the code inside here is we're familiar with from what we looked at so far. So before we start looking down through it, this class here has a constructor. It looks like it has some private properties. They're okay for now. It has a constructor, and the signature of the constructor is dictated by this superclass. So I can tell you that the constructor takes 3 arguments. The first argument is the scope of the various resources that you're going to create inside here. And the scope will always be the current stack. The second argument is just a unique identifier that you want to give to your instance of your custom construct. And the third argument is kind of open-ended. Third argument is going to be an object, what we call a props object. And the shape of that is completely dependent on what you want the custom construct to do. So I've said that this third argument in my constructor, its type is this, and that I've defined this type myself here at the top of the file. So in short, what I'm saying is that I want to pass in the ID of the user pool, the ID of the client associated with that user pool. I want to pass those 2 values into my custom construct here. And so the way you do it is you define a type that represents the shape of the third argument, the props argument of your construct. And if I go back to my class file, just going to leave this open. Sorry, if I go back to my stack file, and here's where I create an instance of my custom construct. And indeed, the scope is this, which is the current stack. This is the ID that I want to give to my custom construct. And this then is the props object that I want to pass into it. And it does contain the exact same, or it contains the 2 values that I indicated in the custom type that I showed you there a moment ago. So back to my custom construct. All I'm doing here is I'm extracting the user pool ID and the user pool client ID. I'm extracting those from the props object, and I'm just storing them up here locally so that any method inside in this class will be able to access them by just referring to them up here. Sorry, these 2. We'll come back to this in a moment. And here we go. We are creating a REST API. So the code that I've highlighted there now is all about creating this guy. I add a resource to my web API, and I've just decided that I want all of the URLs to my authentication web API to begin with auth, just to distinguish it from the URLs that will be targeting the other web API, the kind of what we're calling the application API. So I have two APIs, the auth API and the app API. And then what I want to do here then is just build up the different endpoints in my web API. Now, because all of the endpoints, the code associated with creating each endpoint is going to be similar, just for convenience, I've created a local method. Where's my method? Here it is here. This is just a private method within this class. And as its name suggests, the method is going to be responsible for creating the AWS resources associated with a particular endpoint in my web API. And if we look inside and look, it's creating, it's extending, it's adding a new resource to the web API. It's creating a Lambda, and it's adding a method, the kind of standard RESTful web API stuff. So I don't think you should obviously study this yourself, because I will be giving you all of this code in next week's lab. But there isn't anything particularly new in it other than the fact that we've introduced custom constructs here. Apart from that, I don't think there's anything I need to highlight. Let me just scan it. Now I am passing into my lambdas, because I'm creating a number of lambdas. Into each of the lambdas, I do need to pass down the user pool ID. I need to pass down the client ID associated with that user pool, and I'm passing in the region. Now the actual lambdas themselves are over here in the lambdas folder. And again, for convenience, I've subdivided them. So I've got a whole bunch of lambdas inside in this subfolder called auth. And you can tell from the names of the lambdas, one of them, this one here, let's see. This one here is dealing with the sign up or registration request from a user. This is dealing with these login or sign in functionality. We need to look at these one by one, which we'll do for the rest of this lecture. But each of the lambdas is dealing with one aspect of the authorization stroke authentication kind of process, if you like. The other lambdas, these two here, these are Myriad lambdas that are linked to my actual application. Again, they're kind of dummy, and I've decided to make one of these two lambdas down here, these are down in this part of the architecture. And I've just decided I want one of the lambdas to be protected, which means in order to trigger it from the user side, they have to provide an AWS token, a JWT token. That JWT token has to be a valid token, and only then will the protected Lambda be triggered. The other one is public, and that will always be invocable by any user or any client. Back to my stack file. So this has the effect of creating all of the authentication web API and all of the lambdas behind it. This is pretty much doing the same thing, but for the app API and the lambdas behind it. And, the internals of it are quite similar. So if we look at that custom construct, which is this one here, Okay, let's see. Similar kind of stuff going on, I think. This one doesn't need any private properties because I don't have any private methods. The only reason, I'm jumping around a little bit now, but the only reason that I created private properties within this class is because I want my private method down here to be able to access those values. So for example, let's see, where is it accessing them? For example, here it's going this start user pool client ID, and that this is referring to the enclosing class. So that's what gives it access to the private values up here. Okay. It turns out that I did not need that in the other web API or the other custom construct. So that's why it doesn't have any private properties. And it doesn't have a private method either. So what remains, what's on time? Okay. I think all that remains really is for me to just step through the individual lambdas. Because again, if we go back to here, there's nothing really uniquely different between these two web APIs. They're both just web APIs, and we've seen already how to create a web API in the to-dos example. What we do need to look at though is the lambdas that are here and how they interact with the Cognitor service. We also need to look at this lambda here. So let's see now. If I just do an actual sign up first, so I have deployed that stack, and if I go back to here, this is one web API, and this is my second web API as it would look in the management console. Maybe we just check that. If I go back to the API gateway service, look at my APIs. I now have 3 of them. This is the one that we were looking at earlier on, the to-dos one. These are the other 2 that are linked to the application that we're now looking at. Here's the authentication service, or the auth API. And, here is the various paths that it supports. There's an auth path at the very top. Note it actually doesn't have any methods associated with it. There's a slash confirm, etc., etc., etc. If I just scan down to the sign up, that should really be up. Actually, that's a typo. That should be. Am I right about that? Sorry, that's sign out. Beg your pardon. Why can I not see the? It's just the resolution thing. Here's sign up, and it supports a post request. So if we try and trigger this particular endpoint, let's bring up Postman. So fortunately, I've got a collection already created called, which I've just called Cognito. And if I look at that Postman collection, I've got some variables defined in it. I've got the auth URL and the app URL variables and a token one as well, which we'll come back to. So I now need to set these variables to the actual URLs that were generated. These are the URLs of the two web APIs now. So I need to clear this out and clear out this one. Go back to my deployment. Here are the two URLs, and don't do like I do sometimes, which is get them the wrong way around. So this one here is the URL for the authentication API, web API. Paste that in there. Copy from me. Grab the other one. Save those. Now here's a request for making a sign up. And so the URL is the auth URL and the /auth/sign up. So this part here, that's consistent with what we're being told here. Okay. It's /auth and then /sign up. It's a post request. And okay, we'd have to look at the code to see what's the nature of the payload, but it's predictable enough. The payload is going to look like this, okay? But again, you'd have to look at the actual, that would be part of the specification. So, okay, username, password, and an email, and I'm using my Gmail account. Now, when I send that request, what I'm triggering a Lambda, and we look at the Lambda in a second, but let's just trigger the request first. And it looks like I got a 200 status, so that's good. Now, what it has done is that has triggered a Lambda, or well, yeah, let's just look at the Lambda, I guess. Here's the sign up Lambda. And what does it do? First of all, it creates an instance of a Cognito client. Now, this is the SDK client that my Lambda needs to use in order to communicate with the Cognito service, as opposed to the user pool client, which is something that's being used on the server side. So this is a bit like creating my DynamoDB client when we were doing that in the lab. So create a Cognito client. I'm extracting the username, email, and password from the payload of the request that arrived in my Lambda at my Lambda. The payload is obviously contained within inside the event object, and the AWS Lambda proxy integration would package the payload inside in the event, so I can extract it from the event itself by means of where's the expression? Event.body. Yeah. So I've got these three values. Now, the way I communicate with the Cognito service is similar in style to the way we communicate with the DynamoDB service. You might remember, like we create command objects and then we send a command object to the actual service. That's what we were doing with DynamoDB, and it's the same type of programming model when you're talking to Cognito, and that's not a coincidence. Obviously, the AWS people decided that the SDKs that you use should have the same type of programming style, irrespective of whether you're talking to the DynamoDB service or the Cognito service or the SQS service or the S3 service, etc., etc. So in the case of the Cognito service, and we want to essentially send a request to sign up or add a user to a user pool. So in terms of the command, it's a sign up command that we want to send. Where are we sending it? We create a sign up command here, and then we send it. Where do we send it? Oh yeah, we send the command to via our Cognito client. Here are is the structure of the command object that we need to send, and we're including the user pool ID, the user pool client ID, I beg your pardon, user pool client ID, and then the actual payload that was included in the sign up request. Hopefully, the response back is successful. We're not actually checking, but we should probably check that it's successful. We're just responding with a 200 OK. So this is the Lambda that takes care of communicating with Cognito for the purpose of registering a user in a particular user pool. And it's not the user pool ID that we provide in our request. It's the user pool client ID that we provide. Now I've already sent the request, so that means if I look at my user pool, then we have a user. But if we look at the right here, the user, its status is unconfirmed. So we need now to somehow confirm this kind of registration. And when I created my user pool, I configured it such that the user themselves can change a user status from unconfirmed to confirmed. Just to actually show you where that configuration was specified. If I go back to my stack file and I created my user pool, this setting here, self sign up enabled, what that really means is that you're allowing the user to confirm their registration. Now, how do I confirm it? Well, I need to send a request to the confirmation endpoint. And what actually happened when I registered the user is an email was sent to the email address that I provided, and that email included a code, and I need to now send that code to my web API, my authentication API, as a kind of confirmation that I am the actual person who tried to register in the first place. So if I go to in my case, when I registered, I used my Gmail email account. And so if I open up my Gmail, so here's the actual email that AWS sent to me. And here's the code that I need to use. So if I grab that, back to Postman, and I now need to send a confirmation request. The confirmation request payload needs to include my username and the code that it gave me. Send that request, which it doesn't like for some reason.
Your quotes aren't around the
Yeah.
numbers for the code.
Yeah, good. Well done. Somebody's paying attention.
I try.
Okay, so that was successful. Now, the URL, in this case, the endpoint was the auth URL/auth/confirm, confirm sign up, sorry. And is that one of my endpoints? Should be. Should really have two tabs open, but yeah, there it is there. So that is one of my API's endpoints. It's a post request. And if I looked at my my CDK code, I would discover that that request is forwarded on to or proxied on to another one of my lambdas, which is this lambda here. Sorry, do I include it? There it is there. Same kind of flow really here. You know, you create your uh, Cognito SDK client. I'm extracting the payload from the request. And in this case, it's a confirm sign up command that I want to send. Again, I have to specify the user pool client ID and then the actual payload itself. And the Cognito service then takes care of checking did I provide an actual correct code, or was the code that I'm giving it the code that the Cognito service generated for me? Yeah, so create my command and then send my command. Again, I should really probably be checking whether this is a valid or error response rather than just blindly assuming that it's a valid one. And if I go to my user pool, getting a bit fed up now of jumping around the place, but let's just do it for one more time. Go back to Cognito. And you can see that my user is now confirmed. Okay. So Cognito is just managing the user accounts for me, and it's doing stuff like sending me that um, code, and it'll also be responsible for generating JWT tokens, which we need to come on to. And from a kind of CDK and an application development perspective, what we are doing is, if I go back to our diagram, we're creating this web API and we're writing the lambdas that are talking to the Cognito service. Yeah. We could have put all of the code into one lambda, but better separation of concerns to have separate lambdas, I think, for each of the different types of requests. So we looked at sign up and we've looked at confirmation of sign up. If we now try to log in, we're on to sign in, and I'm actually showing you the lambda, but let's actually sign in. So the payload is as you'd expect, username, password. This is the URL in my case, or the API path name. And if I send the request, that goes through the auth web API onto the Lambda that deals with that request. The Lambda talks to the Cognito service, and the Cognito service will verify my username password combination, and it'll generate a JWT token, and that token will eventually be sent back as a response to, in this case, Postman. Now, the way I've programmed the Lambda, I'm including the token in the actual HTTP response, but I'm also including it as a cookie. And it's probably a little bit better to just include it as a cookie rather than including it in the HTTP response, because that's open to being hacked. But here is the actual token in the HTTP response. And the way with Postman anyway, the way I can find the cookies that have been included in a response, excuse me, is just to go in here. Okay, now we can see the cookies, and there was only one cookie in my case. The name of the cookie was token, and this is the actual value of the cookie. So I'm just going to grab that. And I need to go back to Postman. Sorry, I'm already in Postman. Cancel that. But the token was actually one of my variables. As in here. And I'll just clean out this token. And if I go to my, okay, so right, so that's set up now for, I'm set up now for making requests to the actual app API itself. So I've logged in and I've been returned a token. And if I look at the Lambda that took care of the login processing, which is this one, I think. Yeah. Uh, Same flow again. Create your Cognito SDK client. In this case, the command name isn't obvious. It's initiate authentication, and we pass it these parameters, or we initialize it with these parameters, and then we send an instance of that to my service. Let's see, what am I highlighting here? Okay, we send it and it returns back a structure to us, but I'm just using the destructuring operators here to access a particular property in the object that's returned by Cognito. And within that property, I am digging down into, what am I doing? I'm digging down into this sub property, and that is giving me the actual token, the JWT token, which I am subsequently including in the body of the response, but I'm also including the token as a cookie. So this is the important part, really. I think how do you return data, really, as a cookie, and in our case, the data is the JWT token. So that's just how you actually code it. So now my user has a JWT token, and they can now send requests to this web API if they want to access protected lambdas or protected functionality. But in order to get at the protected functionality, the token that they send has to be, first of all, validated or authenticated. And that is performed by this lambda here, which is kind of the final lambda in our sequence. So let's see, where are we? That's okay. We've looked at that. Okay. All I'm showing you in this screenshot here is, so our JWT token, how do we actually decode it if we wanted to decode it? Well, all I'm showing you here is just a website where you can do it. You can do it programmatically as well, and that might be of interest to us later on. But all I'm showing you here is a screenshot from a website, jwt.io. And if you just paste in a JWT token into the left, then it will show you the decoded form of that JWT token. And the reason I'm just showing you that is because if you look here at the parts that I've highlighted, within the JWT token is the username of the user that that token was issued to. So we can get at that kind of information inside in the from the JWT token should we want to. Although obviously we'd like to do it in a kind of programmatic way, but maybe we'll look at that next week. So now I want to look at this part here, really, I suppose. And again, I have to try and move something that's in my way. Oh yeah. Right. Now I probably should have looked at this maybe when we were looking at, let me think, when we were looking at the web APIs. So for the app API, we have to somehow indicate which endpoints are protected and which aren't. And the way we do that is what I'm kind of showing you here. So, okay, what am I doing? We're creating our, at the very top, we're just creating an empty web API. This is our app API now, as opposed to our auth API. We're adding two endpoints or two resources to the root. One is called protected and one is called public. Okay, and then we're adding a Lambda integration. We're creating two Lambdas. Now the Lambdas we're not really too interested in. They're fairly standard one. They're just going to return kind of standard responses. But we need to create two Lambdas anyway. We're adding, what are we doing here? We're creating three Lambdas actually. Two of them are linked to my backend of my app API. The third Lambda is the one that's going to perform the authentication of the JWT token. Okay, so that's what this one is doing. But it's just a Lambda in one sense. It's no different from any other Lambda. Here is where we make that third Lambda, we give it the role of being the one that's responsible for validating the JWT token. So in the language of API gateway, we call it the request authorizer. Okay, so request authorizer is a construct that's provided by within the CDK framework for this whole purpose, and we are linking it to our Lambda, as in here, we're linking it to our Lambda function. We're also, what else are we configuring it? We're telling it don't do any caching of tokens, which makes sense. And we're telling it where to find the JWT token here. So we're telling it that you'll find the JWT token inside in the cookies header that comes with a request. Now, okay, so that's alternatively, a JWT token could be included as an authentication header, a separate header. So there are a number of options, but I've just arbitrarily decided that the cookie will actually be included in the HTTP request. Sorry, the token will be included in the cookie header of a HTTP request. And here then is where we add our methods to our web API endpoints, but we have to tell it which of the methods require JWT authentication and which don't. And so it looks like this one does, whereas this one doesn't. So again, we're in this case, looks like it's a get method. We're doing our Lambda integration as before, but here's the extra stuff that indicates that this particular endpoint in my app API requires the JWT token to be validated before the request is actually passed on to the backend Lambda. Okay, let's see. Oh yeah, custom authentication. That's okay, I think. So if I try and actually now, if I try and access the protected endpoint in my app API, just from Postman. So it's going to be a GET request. It's the app URL in this case. And this is just the path name of the particular endpoint. Where did that come from? Well, let's go back to the API Gateway service. So it's this web API in this case. And it only has two endpoints. One is /protected and the other is /public, just for demonstration purposes. So it's the /protected one. And it's both GET requests, again, just for convenience. Okay, nearly running out of time. I'm just going to finish this. If you need to bail out, that's okay. You can just watch it out later on. So let's go into the protected one. It's a GET request, and there are a number of headers that I need to set now in this request. Obviously, the cookie header is one that I need to set, which I've done here. Okay, and the cookie header, its value, I'm just taking from the variable that I declared at the Postman collection level. So this is referring to the token that I copied in to here. And at least when I'm using Postman, there is another header that you need to include. And how do I enable it now? Okay, I'm just going to send the request anyway. But there is another header called the host header. If I go back to the slides, maybe it actually illustrates it. So the cookie header is fine, but there is this header called the host header, which for me anyway, if I don't include that header in the request, I get an error response back from Gateway. So you do need to enable that. And let's just send the request. Of course, it wouldn't work. User is not authorized. That sounds like a token issue. Actually, there's the header there now. Just going to quickly try and fix this, and if I can't, then I'll cover it the next day. So when I do sign in, sorry, go back to here. And here, did I save that? I wonder, is that the issue? Okay, no, I'm actually gonna stop here now. Gone way over time, really. I'll wrap up this stuff the next day, and also the next day I'll give you the outline, the specification for assignment 1, which surprise, surprise, is going to involve using API Gateway, Incognito, and Lambda and DynamoDB. All right, sorry for going on a little bit. I'll talk to you next week, and there is a lab there that you can be working on if you want to in the meantime. Thanks. Bye-bye.
Bye bye.